Today we are discuss about reaction of enamine with various electrophile in Stork enamine reaction. First of all, cyclohexanone react with morphine, that is secondary amine. In presence of acidic media, we get imine as a product. This alpha carbon is electronegative in nature, so attached hydrogen is electropositive. So this bond shifted here as a double bond, and this pi bond is shifted towards the more electronegative atom, that is nitrogen, as a lone pair, and we get enamine as a product. First, in acid chloride, this carbonyl carbon is electropositive in nature because chlorine is attached to this carbonyl carbon. Nitrogen lone pair gives back its electron here, and this pi bond attack on this carbonyl carbon, and this pi bond is shifted towards the oxygen and revert back, and chlorine atom is removed. So in next step, this carbon alpha carbon and this carbonyl carbon bond formation occur, and upon hydrolysis oxygen lone pair attack on this carbon, and this pi bond shifted towards the nitrogen as a lone pair. In the very first next step, nitrogen lone pair abstract this hydrogen, and this bond shifted towards the oxygen. In this next step, this bond is shifted towards here, and this group is leave, and we get ketone as a final product. In alpha haloester, ester group NBr is more electronegative, so attached carbon is electropositive in nature. Nitrogen lone pair donates its lone pair here, and this pi bond attack on this carbon, and Br is removed. We get this product, and this product alpha carbon and this carbon between new bond formation occur. Upon hydrolysis, oxygen lone pair attack on this carbon, and this pi bond shifted towards the nitrogen as a lone pair. In next step, nitrogen lone pair abstract this proton, and this bond shifted on oxygen, and this bond shifted towards the oxygen as a carbon double bond oxygen, and this group is leave, and we get ketone here in final product. In vinyl cyanide, cyanide group is electronegative in nature, so it's withdraw the electron from this pi bond, and this methylene group is electropositive in nature. Nitrogen lone pair donates here, and this pi bond attack on this methylene group. So bond formation occur on this carbon and this CH2 group. In very first next step, this bond shifted here as a double bond, and this bond is shifted towards the nitrogen as a negative charge. So further negative charge is revert back its negative charge to the bond, and this bond open up on the carbon atom as a negative charge will abstract the proton from the solvent, and we get this product. Upon hydrolysis, instant this bond is break, instead of nitrogen we put oxygen here and get final product. In alkyl halide, halide is more electronegative, so this attached alkyl group is electropositive. So nitrogen donates its lone pair here, and this pi bond is attack on this alkyl group, and halide is removed. We get this product. A new bond formation between alpha carbon and this alkyl group. Upon hydrolysis, this bond is break, and instead of nitrogen we put oxygen over here and get final product. In allyl halide, Br is attached to this CH2 group, and Br is more electronegative, so attached carbon is more electropositive. So nitrogen lone pair donates here, and this pi bond attack on this carbon, and Br atom is removed. Alpha carbon and bond formation between alpha carbon and this CH2 group. Upon hydrolysis, this bond is break, and instead of nitrogen we put oxygen over here and get this final product. In proprasyl halide, this Br is more electronegative, so attached carbon is electropositive. Nitrogen donates its lone pair here, and this pi bond attack on this carbon, and Br is removed. Alpha bond formation occurs between this alpha carbon and this CH2 group. Upon hydrolysis, this bond is break, and instead of nitrogen we put oxygen over here and we get this final product. In alpha haloketone, this CH2 group is more electropositive because Br atom is attached to this CH2 group. Nitrogen donates its lone pair here, and this pi bond attack on this carbon, and Br is removed. Bond formation between this carbon, alpha carbon, and this carbon occur. We get this product. Upon hydrolysis, this bond is break, and instead of nitrogen, we put oxygen over here to get final product. In cyclogen chloride, this carbon is more electropositive because nitrogen and chlorine atom is attached to this carbon atom. Nitrogen donates its lone pair, and this pi bond attack on this carbon. At that same time, this bond open on nitrogen atom and again revert back to this bond, carbon nitrogen bond, and this Cl group is removed. Upon hydrolysis, this bond is break, and instead of nitrogen we get oxygen here, and this product is formed. In alpha beta unsaturated ester group is electron withdrawing group, so it's withdraw the electron from this pi bond, and this CH2 group is electropositive in nature. Nitrogen donates its lone pair here, and this pi bond attack on this carbon. At that time this pi bond shifted here, and this bond is open up on the oxygen as a negative charge. We get this molecule. Bond formation occurs between this carbon and this CH2 group. Now this negative charge donates its lone pair here, and this pi bond open on this carbon atom as a negative charge, and will abstract the proton from the solvent. We get this molecule. Upon hydrolysis, this pi bond is break. Instead of nitrogen, we put over oxygen here and get final product. In alpha beta unsaturated ketone, this carbon is more electropositive because oxygen is electro-withdrawing group, so it's withdraw the electron from this pi bond. So nitrogen lone pair donates here, and this pi bond attack on this carbon. At same time this bond shifted here, and this pi bond open up on the oxygen atom as a negative charge. New bond formation occurs between this alpha carbon and this carbon. And next step, negative charge oxygen negative charge revert back its electron here, and this bond open up on the carbon atom as a negative charge will abstract the proton from the solvent. Upon hydrolysis, this pi bond is break, and instead of nitrogen we get put oxygen over here and get final product. Thank you.